Today we're going to start a new topic called counting. And the situation we have here is you're at a coffee shop and you need to order a cup of coffee. At this coffee shop, to order a cup of coffee, you have to first pick a size, pick a temperature, and then pick a type of roast. And the question is, what are all the possible ways that you can order this cup of coffee? So one way is you can go small, iced, light. That's one way. What's another way? You can pick medium, hot, dark. That's another way you can order this cup of coffee. And what I want to do here is list out all of the possible ways that I can order this cup of coffee. And I want to do it in a way that's organized. So I'm going to use what's called a tree. So don't worry about writing this down because I'm not going to ask you to do this on a lab. So just pay attention for the next couple minutes. So to draw my tree, I'm going to start first with the customer. So when the customer enters this shop, they have to first pick a size. Okay, what are the options that they can pick for size? They can pick small, medium, large. After they pick a size, they pick a temperature. Okay, so after they pick a size, say they pick small, now they have an option of going hot or iced. So from this small, after picking small, they can either go hot or iced. Okay. Similarly, if they went medium, after they pick medium, they would have an option of hot or iced. And then if they pick large, they can now pick hot or iced. Now, what happens after they pick the temperature? After they pick a temperature, they have to pick a roast, and they have an option of dark, light, or decaf. So from each of these temperatures, they have three options. Dark, light, decaf, I'll call DE. Okay. From this temperature of ice, they have three options. Dark, light, decaf. Same thing for this one. Dark, light, decaf. Dark, light, decaf. And then for this last temperature, dark, light, decaf. And this actually represents all the possible ways that I can order this cup of coffee. Each path represents one way that I can order coffee. So for example, let's talk about this path right here. What does that path represent? That path represents a customer going small, iced, decaf, right? So this path represents small, iced, decaf. Okay, let's try another one. What does this path represent? That path would represent someone going medium, iced, light, right? Medium, iced, light. And so on. So each path, which I'm not going to go through and write what each path represents, but each path represents one way that a customer can order a cup of coffee. And our question was, how many different ways that can they order coffee? So in other words, how many different paths are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like there's 18 different ways that a customer can order a cup of coffee. Now, that was a little annoying to have to draw this picture. So the question is there another way that I can get to this 18 without having to list out all the possibilities? And the answer is yes. And we're going to use what's called the counting principle. The counting principle says when a task consists of case-separate parts and satisfies the uniformity criterion. So for now, don't worry about uniformity criterion. I'll explain what that is a little bit later. When a task consists of case-separate parts. So on the front page, our task was to order a cup of coffee. And that task you can break up into three separate parts or three separate choices. Because you have to first pick a size, that's 1. Pick a temperature, that's 2. Pick a roast, that's 3. Okay, so when you have a task that you break up into parts, what you do is I'm going to list out those parts or those choices you have to make. So you have to first pick a size. And then you pick a temperature. And then you pick a type of roast. So ordering a cup of coffee involves 3 separate parts or 3 separate choices that we have to make. And what you do is for each part or each choice, count how many options you have. For size, how many options do we have? For size, you can have small, medium, or large. So for size, we had 3 options. For temperature, how many options do we have for choosing temperature? Hot, iced, 2 options. For roast, we could choose dark, light, or decaf. So for roast, we had 3 options. And what the counting principle basically says is after you count how many options you have for each part or each choice, multiply them together. 3 times 2 times 3. What is 3 times 2 times 3? It's 18. Which matches what we had when we did the long way by listing out all the possibilities. Now, the fine print you have to pay attention to is that for this counting principle to work, the situation has to satisfy the uniformity criterion. And what that basically means is that the number of options you have for a particular part should not depend on what you chose for the other 2 parts. Okay, so imagine a more complicated coffee shop where the iced drinks only come in medium or large. Right? So in that situation, the number of options you have for temperature depends on what you chose for size. Right? If you chose small for size, then you would only have hot as an option. So if I chose small for size, then the options for temperature will be 1 because our ice drinks don't come in a size of small. So if I chose small, then I have 1 option for temperature. If I chose medium, I have 2 options. If I chose large, I have 2 options. So in a situation where the number of options for a certain part depends on what you chose for another part, that's a more complicated situation where the counting principle does not apply. So for those complicated situations, you would have to do it the long way by listing out all the possibilities and then counting. The good news is that for the questions we're talking about in this class, the counting principle does apply. All right, so let's try some examples where we use the counting principle. Example 1. So here we are at a pizza restaurant, and to order a 1-topping pizza, customer has to choose a size, a crust, a sauce, and a topping. Okay, and these are our options for size, options for crust, options for sauce, and options for topping. How many ways can a customer order a 1-topping pizza as described above? To use the counting principle, you have to first decide how many blanks you need. Okay, that's how many choices you have to make to order this 1-topping pizza. We have to choose a size, that's 1, crust 2, sauce 3, and topping 4. So there should be 4 choices. So 4 blanks. Okay, the first one was for size. Second one was for crust, sauce, and topping. And all you do is for each blank, count how many options you have for each blank. For size, I can choose personal, small, medium, large, 4 options. For crust, I have pan, hand tossed, thin, stuffed. That's 4 options there. Sauce, marinara, Alfredo, pesto, barbecue, buffalo. How many is that? That's 1, 2, 3, 4, 5. 5 options for sauce. For toppings, pepperoni, sausage, bacon, mushrooms, olives, onions, peppers. That's 1, 2, 3, 4, 5, 6, 7 options for toppings. And then all you do is multiply those together. So 4 times 4 times 5 times 7. And that's 560. So there's 560 ways that a customer can order a 1-topping pizza at this particular restaurant. Now, on your lab, you don't have to multiply it all together and get a final answer. You can just enter it as 4 times 4 times 5 times 7. Okay, so I'll have another video at the beginning of the lab where I give you more details about how you should enter this in. Example 2. In California, license plates for trailers follow the format: a digit followed by 2 letters followed by 4 digits. The letters I, O, Q, and S are not allowed. That's probably because I looks like a 1, O and Q look like a 0, and S looks like a 5. That's probably why they're not allowed. If repetitions are allowed, how many different California license plates for trailers are possible? First thing we need to do is decide how many blanks we need. So think of making a license plate as choosing each individual digit or letter. So we have a choice for digit. I'll label that with a D. 2 letters, letter, letter, and then 4 digits. 1, 2, 3, 4, and these are digits. And then go through for each blank, count how many options you have for each blank. First blank is digit. So when I say digit, I mean 0 through 9. So 0 through 9. 0, 1, 2, 3, 4, 5, 6. Okay, those are digits. How many options do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 options there. Letter. Okay, so letter, I mean A through Z. So normally A through Z, how many letters is that? Pretty sure it's 26. 26 letters. Now, I did say we're not allowed to use I, O, Q, and S. Okay, so 26 letters total. But if you remove I, O, Q, and S, how many letters do you have now? So 26 minus 1, 2, 3, 4, minus these 4. 26 minus 4 will be 22. We have 22 options for letters. Letter, 22. Digit, 0 through 9, that's 10. Digit, 0 through 9, 10 again. Digit, 10, digit, 10. And technically, you should multiply those together. So 10 times 22 times 22 times 10 times 10 times 10 times 10. But on your lab, you don't have to multiply them and get a final answer. You can just type in 10 times 22 times 22 times 10 times 10 times 10 times 10. Second part. What if repetitions are not allowed? So notice that for the first part here, repetitions are allowed. Now, what if repetitions are not allowed? What's the difference? Let me first copy the blanks. So digit, letter, letter, digit, 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 digit. Okay. Now, the first time you fill in a digit or a blank, or digit or letter, it should be the same as the first part. Okay. Digit, 0 through 9. How many options do we have? 10. Same as before. Letter, this is the first time we're doing letter. Letter, A through Z, but you remove I, O, Q, and S. So 26 minus these 4, that's 22 options. Now, the second time you use a digit or letter, you have to now think. Okay? This next L, this is now the second time we're doing a letter. So normally, if repetitions are allowed, it will be the full 22. Okay, but repetitions are not allowed, which means whatever letter I picked for this first L, I can't use again. So I don't have the full 22 options for the second L. I should be down by 1 to 21 options. Okay, so if repetitions are not allowed, you have to remember to reduce the number of options. Next is digit. Okay, this is the second time we're using a digit, so we do have to reduce. So normally, if repetitions are allowed, we would have the full 10. But because repetitions are not allowed, I used 1 digit already in this first slot, so I'm actually down to 9. Next one. Okay, normally, if repetitions are allowed, I would have the full 10, but I actually used 2 digits already, so I'm actually down by 2 to 8. Okay, next one, I'm down again to 7, and then next time I use a digit, I'm down again to 6. So Pay attention to whether repetitions are allowed or repetitions are not allowed. Example 3. Maya wants to create a door code consisting of 3 letters followed by 3 digits. She wants the code to start with N, M, H, or L and end with 8, 2, or 3. She does not want any repetition, so keep that in mind. So no repetitions. How many different codes can she create? So first of all, decide how many blanks you need. So I need 3 letters followed by 3 digits. So 3 letters, 3 digits. Okay, now in the first example, example 2, right, I told you to not use I, O, Q, and S. Okay, so I told you letters not to use. This one's a little different because I'm telling you she wants the code to start with N, M, H, or L. So I'm telling you the letters I want you to use. And that's for the first blank. So first blank, I want you to use N, M, H, or L. And then in with 8, 2, or 3. So I'm telling you the last blank, I want 8, 2, or 3. So slightly different than example 2. Example 2, I'm telling you the letters I don't want you to use, and also that applies to all the letters. Example 3, I'm telling you the letters I want you to use, and it only applies to the first blank and the last blank. So it says she wants to start with this and end with 8, 2, or 3. Okay. It doesn't say anything about the other letters or digits. Okay, so let's go through each blank. So if you have some restrictions on the blanks like we do here, my recommendation is to start with those restricted blanks. So I'm going to fill in the L, the first L, and then the last D first. First L, how many options do I have? I want to use N, M, H, or L, which means I only have 4 options there. Last blank, I want you to use 8, 2, or 3. How many options do you have? 3. Okay. These other blanks don't have restrictions. Let's talk about this second L. Second L is a letter. Letters normally is 26, right? 26 for A through Z. I don't really have any restrictions that I'm telling you not to use, so I should have the full 26. But because I don't want repetition, this is the second L, right? We have a first L here, so this is the second L, so we do have to reduce by 1. So it's not the full 26. This is down to 25. And that's because normally it's the full 26, but because I don't want repetitions, I already use a letter right here in the first blank, which means I'm down by 1 to 25. Next letter, right? Normally it will be the full 26, but because I don't want repetitions and I've used 2 letters already, I should be down by 2 to 24. Digit, so digit 0 through 9, normally that would be 10, but keep in mind that I don't want repetitions and I already used a digit already, so I should be down by 1 to 9. And then the next digit, I should be down by 1 again to 8. Okay, and that's because I don't want repetitions. Next part, what if repetitions are allowed? So let me recopy the blanks. So 3 L's and 3 D's. Okay. First L needs to be N, M, or H. N, M, H, or L. And the last one needs to be 8, 2, or 3. Okay, just like before, I'm going to fill in the most restricted blanks first. So the first blank and the last blank. First one, how many options do I have? I want to use N, M, H, or L, so that's 4 options. Last blank, I want to use 8, 2, or 3. 3 options. Okay. The other ones have no restrictions. So L, so letter. So normally it will be A through Z, so 26. Here we are allowed to use repetition. So if you are allowed, you're going to use the full 26. You don't have to reduce. So this will be the full 26. Letter again, Once again, because we are allowed to repeat, we're going to use the full 26. Digit 0 through 9, so normally that's 10. We are allowed to repeat here, so we're going to use the full 10. Next digit 0 through 9, 10. We are allowed repetitions, so we're going to use the full 10. Okay, so the point here is that pay attention to whether you're allowed repetitions or not. If you are allowed repetitions, you're going to use the full number. If you're not allowed repetitions, you have to think a little bit and figure out how much you have to reduce by. Example 4. If class has 40 students, the teacher needs to pick one student to take attendance, one to pass out papers, one to collect homework, and one to erase the board. How many ways can this be done? First thing you need to decide is how many blanks you need. So I need one blank for the attendance taker, one for the paper passer outer, one for the homework collector, and one for the board eraser. So four blanks. The first one is for the attendance person. Second one, pass out papers. Third one is collect homework. And then erase board. Okay. First blank, how many options do I have for the person who takes attendance? The class has 40 students, which means I have 40 options I can pick for the person who takes attendance. So 40. Next, person who passes out paper. Now, in the last page, when we're talking about license plates and the password, what was it? The code, right? I told you to pay attention to whether it was whether you were allowed to repeat and whether you were not allowed to repeat. When we're talking about people, if it doesn't say anything, we're going to assume that we're not allowed to repeat. Okay, so talking about people here, we're going to assume here it doesn't say anything, so we're going to assume that no repetitions are allowed. So no repetitions. And that's because whoever I pick to take attendance, I don't want to pick the same person to pass out papers, right? I don't want to pick the same person to do two jobs. Okay, so because no repetitions, for the second blank, I don't have the full 40 anymore, right? I picked one person for attendance already, which means I should be down to 39. Third blank, I don't have the full 40 anymore. I should be down again to 38. And then last blank, I should be down again to 37. Second part of the question here, the 40 student class includes Ellen and Jose. How many ways can a teacher pick students to take attendance, pass out papers, collect homework, and erase the board so that either Ellen or Jose takes attendance and the other person erases the board? Let me recopy my blanks. Attendance, pass out papers, collect homework, erase board. Okay, so in addition, I have restrictions, right? I want either Ellen or Jose to take attendance, and then the other person to erase the board. So the first blank, I want to be either Ellen or Jose. The last blank, I want to be Ellen or Jose also. Okay, so this is very similar to the code example here, where I'm telling you what I want you to use for the first blank and what I want you to use for the second blank. So same situation here. I want you to use Ellen or Jose for the first blank and Ellen or Jose for the second blank. And it doesn't always have to be the first and last blank. I could say I want Ellen or Jose for attendance and then the other person to collect homework. So it doesn't matter that's the first and last blank. Okay. Now, whenever you have restrictions like this, my recommendation is to fill in the blanks with the restrictions first. So the first blank, I want Ellen or Jose to take attendance. So how many options do I have? 2. Last blank, I want Ellen or Jose So you may think it's 2, but it's not 2. Remember, no repetitions when we're talking about people. Because I already chose Ellen or Jose here, for this last blank, I don't have the full 2 anymore, right? I have one person in attendance already, which means I'm down to one person left for that last blank. For the blanks in the middle, I have no restrictions, right? Normally, it would be the 40 total in the class, right? But because we're talking about people, repetitions are not allowed. I already used 2 people for the first blank and the second blank. So now I'm down to 38. Okay, and that's, once again, that's because I have 40 people total, but I chose one person for the first blank already and one person for the second blank already. In other words, Ellen and Jose are out, which means there are 38 people left. And then for this last blank, I should be down again to 37. Example 5. Family consisting of 3 children and 8 adults have reserved a row of seats at a theater. The 3 children need to sit in the middle with 4 adults on either side. How many ways can the family seat themselves? How many blanks do I need? I have the 3 children in the middle. 1, 2, 3. These are children, children, children. And then I need 4 adults on either side. So 1, 2, 3, 4 adults. And then 1, 2, 3, 4. Okay, let me start with the children in the middle because it looks like those are the most restrictive. For the first child, how many options do I have? There's 3 children total. So for the first child, I should have 3 options. Okay, we're talking about people here. So once again, no repetitions. For the second child here, because there's no repetitions, I don't have the full 3 anymore. I should be down 1 child to 2. And for the same reason, I should be down another child to 1. Now let's go through and fill in the adults. The first adult, how many adults do I have total? I have 8, right? So the first adult, I should have the full 8. The next adult, because I'm not allowed repetitions, and I already chose 1 adult already, I should be down to 7 here. And then down to 6, down to 5, down to 4, down to 3, down to 2, and then down to 1. All right, that's it for this lecture. Have a great day. See you all in the next one.